Hello, students. I anticipate these will be the notes for Monday's class. We will likely spend 2 days in class working on equations of lines. So there will probably not be any notes for Thursday night, but these will be the notes for over the weekend for Monday's class. So let's have a look. Our objective for Monday will be the student will discover the properties of slope for parallel and perpendicular lines. I believe Monday's date would be the 21st, if I'm not mistaken. So copy down your objective and your date, and press pause if you need more time to copy anything down, and then hit play when you're ready to move on. Okay, now there's just a basic fundamental question that goes along with lines being parallel and perpendicular within a graph. Okay, so what is it about a line that makes it behave in a graph the way that it does? Okay. Well, we've said all along that there's only two things that a line needs in order to do what a line does. It needs somewhere to begin, and then it needs somewhere to go. So the somewhere to go is all based upon slope, and we've been talking about slope. Whether a graph goes up as it moves from left to right or down from left to right, whether it is moving in a big hurry, being more vertical than horizontal, or being slowed down, being more horizontal than vertical. Okay, so when you have more than one line in a graph at the same time, the only way that they will interact with each other will be to examine their slope values. Okay. So it's going to be the slope values of two lines that will force them to be parallel or perpendicular to each other. Now, two basic rules here. If two lines have the same slope value, then they are parallel. And if you get to thinking about this, it makes perfect sense. If two lines are not going to intersect in a graph, they must be rising and running at the same rates. Otherwise, they would eventually cross over each other, making them not parallel. So they're going to have the same slope value in order to be parallel. On the other hand, being perpendicular is a little bit more complicated. Not only do the lines need to hit, they also need to hit in order to form a right angle. The only way that this will happen in a graph is if the two lines have slope values that are negative reciprocals of each other. That will make them perpendicular. Now, it's probably not the first time you've heard this term, negative reciprocals, but here is the definition anyway. Negative reciprocals basically means if you take one fraction and flip it upside down and change the sign. Okay, that's a negative reciprocal, turning a fraction upside down and changing the sign. If by doing that it changes one of the slope fractions for one of the lines and makes it identical to the other slope fraction for the other line, then you will have lines that are perpendicular to each other. Okay, so we'll just start with little baby steps here. What do you know about the following two lines? We have two equations, y equals 2x minus 5 and y equals 2x plus 13. Okay. Well, very clearly, the slope values are the same between the two lines. They both are rising 2, running 1. That means that they are going to be parallel to each other. Okay. Where they cross the y-axis is irrelevant. Parallel lines can be very near each other or they can be miles apart on the graph. The only thing that is important is that their rise and run are the same rate, same slope value. Okay, so here's two other lines, just getting our feet wet again. What do you know about the following two lines? Y equals 3/4 x minus 5 and y equals negative 4/3 x plus 13. Obviously, this time the lines are not parallel because the slope values are not equal. However, these lines are going to be perpendicular to each other. And the reason they're going to be perpendicular is because of the negative reciprocal rule. If we take one of the slopes and turn it upside down and change the sign, if that gives us the other slope, then we have lines that are perpendicular. So let's take a look here. I took the 3/4 from the first line, the slope from the first line, turned it upside down, did the reciprocal. That gave me 4/3. Changed the sign from positive to negative. That gave us negative 4/3. Is that the slope from the other line? Very clearly, yes it is. Okay, so they are perpendicular, and once again, it is not going to necessarily be important where they cross the y-axis. It is the slope values that are going to tell us that the lines are perpendicular. Okay, so what is the slope of any line that is parallel to the line 2x plus 3y equals 4? Now, with this line, we cannot tell where our what our slope value is. A lot of people will fall into the trap of assuming that the slope value is always the number in front of x, always the coefficient of x. But you've got to remember that slope is the coefficient of x when the equation is in slope-intercept form. So that needs to be the first thing that we do. We cannot read the slope or the y-intercept or determine if we have parallel or perpendicular lines really until we get it in a slope-intercept form. So we're going to take this equation, 2x plus 3y equals 4. We're going to run it through our steps to solve an equation, keeping in mind that y is our value that we're looking for. Okay, so remember my little 5-step thing. Parents' complaints vary for every one. Okay, P for parents is for parentheses. We don't have any parentheses. We don't have to worry about that. Complaints is for combining like terms. There are no like terms to combine. Vary means all your variables go one direction. Well, the y's are already together, so we don't have to worry about that. Every is for everything else going the opposite direction. So if all of our y's are on the left, that means everything else needs to go right. That includes the two x's. They do not need to be there, so we're going to subtract them away to the other side. The left side will leave only 3y, and on the right side, the 2x and the positive 4 will not combine because those are not like terms. Okay, 4 is a constant. It will only add or subtract with other constants. Negative 2x is obviously an x. That will only add or subtract with other x's. The last thing we need to look for is our 1 and 1, positive 1 coefficient for our variable, positive 1 exponent for our variable. We currently have 3 y's. We do not want 3 of them. We only want 1. So we will divide both sides by 3. And that means we have to hit every single term with a division by 3. Okay. We get negative 2/3 of an x, and we get 4/3. And more importantly, we have found our slope-intercept form. So we ought to be able to decide what is the slope of any line that is parallel to 2x plus 3y equals 4. Well, what is the slope of this line? It is negative 2/3, as we just found. So any line that wants to be parallel to this line must also have a slope of negative 2/3. That's your answer. What if the equation or the problem had said, what is the slope of any line that is perpendicular to this line? Well, I'm not going to go through the step-by-step on getting this from a standard form, which it's currently in, to slope-intercept form, which we already got it to. We will simply jump back and get that value again, negative 2/3 x plus 4/3. Now we want the slope of a line that is perpendicular to this one. Okay, so how do we get the perpendicular part? We take our slope, we do the negative reciprocal, and that should tell us what we need in order to be perpendicular. Okay, so our negative 2/3 becomes negative 3/2. Change the sign from negative to positive this time, and you have found your slope. And the slope of any line that wants to be perpendicular to this one must be positive 3/2. Okay, a little bit more complicated. There is a line passing through points negative 5, 3 and 5, 9. What is an equation of any line that is parallel to this one? And also, what is an equation of any line that is perpendicular to this one? Well, obviously the problems are asking us about being parallel and being perpendicular, and in a graph that has to do with slope. So we need to know how this original line is sloping. Okay, they gave us 2 points on the line. Can we find out slope based upon 2 points on a line? Absolutely. That's what our slope formula is for. Okay, so we're going to go through our basic strategies again. We are going to take our 2 points. We are going to label them x1, y1, x2, y2. We're going to write down our slope formula with nothing plugged into it yet. Then we are going to plug in our values and calculate our slope. Okay, in this case, y2 is going to be a 9, y1 is a 3, x2 is a 5, x1 is a negative 5. Pay special attention to make sure you don't lose or confuse any of your negative signs. In the numerator, 9 minus 3 is 6. 5 double negative 5, that's the same thing as 5 plus 5, which is 10. We have 6 over 10 as a slope, which will reduce to 3 over 5. So to address the questions, what is the slope of any line that is parallel to this one? Okay, well, what's the rule for lines being parallel to each other? What do their slopes have to do? Their slopes must be equal. Okay, so our equation of our line will be y equals 3/5 x plus, and we said it does not matter where our line crosses the y-axis. What makes it parallel is the slope, so we can make up any y-intercept that we want because they kind of left that open-ended for us. Second half of that question, what is the slope of any line, or the equation of any line perpendicular to this one? Now it's got to have a negative reciprocal slope, so 3 over 5 will become negative 5 over 3. So our equation of a line perpendicular to this one would be y equals negative 5/3 x plus whatever. Okay, it does not matter where it crosses the y-axis. What matters is they intersect to form a right angle, and that happens because of the negative reciprocal slope. So we can put any value in for our y-intercept at this case, in this point. Okay, so I just picked any number, negative 32 this time for no particular reason, and there's an equation. Now I have one more example that I will be going over with you at the first of class on Monday. But go ahead and copy it down, and if you're understanding everything, probably won't take you more than just a couple of moments to fill it out yourself. So copy this one down, give it a go. Write the equations of the lines parallel and perpendicular to 4x minus y equals 3, assuming they have the same y-intercept as this given line. Copy it down, give it a try. I'll see you in class on Monday. Hope you have a good weekend, and that is all.